Let's talk about intercepts. For any polynomial function, an intercept is where the graph of the function crosses one of the axes in the plane. Specifically, the x-intercept or x-intercepts is where the graph crosses the x-axis. Functions can have 0, 1, or several, up to the degree of the polynomial, number of x-intercepts. And the y-intercept is where the graph crosses the y-axis. Notably, every polynomial has only exactly one y-intercept, but it can have multiple or no x-intercepts, depending on the problem. In order to find an x-intercept, remember, they all have a y value of 0, which means we can set y equals 0 and then solve for x, figure out what values of x cause the equation to be true. Similarly, to find the y-intercept, since that has an x value of 0, we can set x equals 0 in the problem and then simplify the polynomial in order to find the y-intercept. Let's do an example. It says find all intercepts for the following polynomial. Let's start with the x-intercepts. We'll notice that if we wrote this polynomial out, we have 1, 2, and then another 1. This polynomial would have a degree of 4, meaning that they can have up to 4 x-intercepts. How do we find them? Well, for the x-intercepts, we set y equals 0. In this case, y equals f of x, our left-hand side, and so we will set 0 equals x minus 1, x plus 2 squared, and x minus 3. At this point, we want to solve for x, and we'll notice that since this is already factored, this is actually pretty straightforward. Either this term has to be 0, this term has to be 0, or this term has to be 0. So let's write out those cases. X minus 1 equals 0, or x plus 2 squared equals 0, or x minus 3 equals 0. Each of these produces its own x-intercept. X equals 1, x plus 2 equals 0, so x equals negative 2, and finally x equals 3. Although I said we could have up to 4, this one has in fact 3 x-intercepts. Now to find the y-intercept, remember we set x equals 0 and then simplify. So anytime we see an x, we're going to write it as a 0. That's 0 minus 1, 0 plus 2 squared, and 0 minus 3. If we evaluate this, this gives us negative 1 times 2 squared times negative 3. That's going to work out to be positive 12. Every polynomial has only a single y-intercept. This one is y equals 12. In class, we are going to identify graphs of polynomials. We're going to talk about the end behavior as the function approaches plus or minus infinity. We're going to look at multiplicity of zeros and define what that means, and talk about how to graph polynomials. See you there.